We're trying to use these three mini equations to make the overall equation, and you have to manipulate them so that they equal this. Let's start with that. You're probably already familiar with it, but I'm going to look at each of the equations and see what they have that's unique to them, like which letter they only have that's also in the overall equation, because that's going to be our most helpful thing. So if I look at this first one, we have G in the overall reaction, and we have E in the overall reaction, and nothing else. And see, G is nowhere else in here, and neither is E. So both of those are telltale, and we go from 2 to 4, from 1 to 2. So this, I can see, has been doubled. So I'm just going to put a 2 there. And then question is, what do we do to our K? We'll get there. Then with this one, we see, okay, there's an H. I don't see one of those in there. There's an I. It's on the other side, but there's also an I here, so it's not unique. We'll come back. 8F, not in there. 4J, also not in there. Okay, so we'll come back to this guy. Lastly, we have this one. We've got 3L. Okay, L isn't anywhere else, but it is in the overall equation. Again, I is not unique, but it is in there. 2J, J is not in there. K is, though, and it is unique. No other equation has K. So this has an L on the opposite side. K has it on the opposite side. So we must have flipped this equation. So I'm going to reverse it. And also there are 2 Ks and 6L, so I'm also going to double it. So we already talked about reversing it is going to flip your equation, because now whatever was your product is now on the top. So instead of having JK over LI, we now have LI over JK. So now the K for this one is going to equal 4 just for the flipping part. What does changing the coefficients do? And that's where these come into effect. If you are doubling your equation, you're essentially multiplying each of these by 2. And we could factor that out to be simply the whole thing is getting squared. So whatever you're multiplying these by, you're going to raise it to that power. So K1 is going to become 3 squared, or 9. We haven't touched the middle one yet. And then the bottom one is going to be 4 after it's flipped, and then squared. So that will be 16. So the whole point of this thing is talking about manipulating our K values. I wanted to add that if we were multiplying by 3, this would have been cubed. And also, if this had been needed to be divided in half, for example, if we needed like 1 of those and 2 of those, whatever. So if we're dividing this in half, then this would be raised to the 1/2 power, or the square root of 3. So we're not doing that though. I just wanted to mention that. So now that we know how to manipulate the K's, let's go back to those 3 equations, figure out what to do with the third one. We need to still get to that overall equation. So I've moved the 2 equations that we've already changed over to the right here, and let's see if anything cancels. No E's, F, G, H, no. Nothing cancels so far. So hopefully our middle equation can help us out here. Let's look at this first 6H. We have a 6H here. It's not in the main equation. We want those to cancel. So I'm going to leave the equation as is and see how that goes. So I'm going to put my 6H. And I can see here that my 6H will cancel that. My I will cancel one of these I's. The 8F's will cancel, and so will the 4J's. That leaves us with an overall of everything on the left becoming, if I go and look, that is exactly what we should have. Perfect. Now to combine the k's. If I take the k's in their rearranged and multiplied value, so I've already multiplied my g times 2, so that would be g squared h6. And you can see that my k3 is flipped, so that the what used to be the products are now on the reactant side. So if I want to make my k, we've already mentioned that we're multiplying them, but why? And the answer is, that's how you get things to cross out. So if you multiply these, then you'll get your h6 crossed out, one of the i's, j4, f8, there it is. And I think that is what remains for us, g squared, and we've got 1i and L to the 6th all over e to the 4th times k squared. And we look, e to the 4th k squared, j squared, L to the 6th I, that's what we want for our k. So understanding what equilibrium is, really focusing on this being the equation for k, allows you to manipulate it a lot easier. Let's finish up the last little bit of this equation, just so we have an answer to go off of. We're going to be multiplying then our 9 times our 1/2 times our 16, and that will get us a grand total of 72. So that is our final k, in case you were looking for an answer. So hope that makes sense.